this section that was connected right here is what is lost to the phosphoglycerate. Okay? So now we've got the CO2 molecule, which is in red here, incorporated into the second portion of the molecule here. We've released a phosphoglycerate. So this is where the Rubisco has cleaved that 2,3 bond, right? So this was the portion where they create the carbon-carbon bonds. Okay, so I mentioned the things that Rubisco does. Creates that carbon-carbon bond from CO2. So that's the first step right here. Then is able to cleave this bond here, creating our 3-phosphoglycerate. Okay, now the lysine residue at 175, this is the one we talked about before, we have another lysine residue, is deprotonated. Oh, there it is. I was like, where's the second one? And we release our second molecule of 3-phosphoglycerate. Yeah?
What carbon is cleaved? Is it carbon 3?
It is 1, 2, 3, this one right here. Yeah. So we have the protonation, the lysine from 175 releases it, has a deprotonation, we protonate, and we create our second molecule of 3-phosphoglycerate. Okay. So let's just talk a second about the regulation of Rubisco. So Rubisco is highly regulated. Okay. It is regulated mostly at the first step that requires CO2. Okay. So it is regulated based on the availability of CO2. So it is inactive if that lysine is carbonylated by CO2 and the lysine is unacceptable, okay? Or unaccessible right here. It is also inactivated by an enzyme called Rubisco activylase that is sometimes triggered by light. So this is one of the ways that this portion of photosynthesis is regulated by light, even though it's not requiring light. Okay. The reaction of the Rubisco activase requires ATP as well. Okay. So I'm going to go back to that in a second, maybe on Friday. The second one I wanted to talk about is another nocturnal inhibitor. So this is an enzyme that inhibits Rubisco because it looks like that beta keto intermediate. So at this point in this structure, that molecule looks like this intermediate. So just like we talked about with enzyme inhibition, it's a competitive inhibitor and will stop the cycle from happening. This is also synthesized in the dark. So as this molecule increases in the dark, it inactivates the Calvin cycle. Another way that light is regulating the Calvin cycle without light actually being required. And we're like totally out of time. Anybody have any questions? All right, I will see you guys in lab today.